we're given this problem for independent and dependent variables. So it says these marbles are placed in a bag and 2 of them are randomly drawn. What is the probability of drawing 2 yellow marbles if the first is not placed back in the bag for the second draw? Well, let's pretend that it is placed back in the bag. Let's do it that way because I already did those problems in Screencastify wasn't cooperating. So let's pretend if they were placed back in the bag, what we would have is 2 marbles out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 out of 10 chances times 2 out of 10 chances. But with this one, our first chance to draw a yellow marble is 2 out of 10. Multiply that by our second chance where it's not placed back in the bag. So then we only have 1 marble out of a total of 9 marbles because we've lost a marble. We haven't lost all our marbles, not quite yet. So that's a good place, I guess. Okay, I set up my problem. Give your answer as a rational number. Hint, multiply the probability of the first event by the probability of the second event. Okay, so I go 2 times 1 is 2. Multiplying fraction, multiply straight across. Over 10 times 9 is 90. 2 and 90 are both even. So that means I can reduce this fraction. So I'm going to. Since they're both even, I can divide them both by 2. If I divide 2 by 2, I get 1. If I go 90 divided by 2, I get 45. Half of 90 is 45. So my answer is 1 out of 45 chances. When you don't replace the marble for the second draw, what kind of probability is it? It is dependent because it depends on the first draw that affects your probability. These marbles are placed in a bag and 2 of them are randomly drawn. What is the probability of drawing 2 pink marbles if the first one is not placed back in the bag? So my probability of drawing pink marbles is 1, 2, 3. 3 pink out of 10. Times, we did not put the pink one back in the bag, so we only have 9 marbles in the bag, and we already took out a pink one, so 2 chances out of 9 to draw another pink one. 3 times 2 is 6. 10 times 9 is 90. These are both even numbers, so I'm going to reduce the 6 and 90 chance, but I'll write that in easier terms to understand, smaller numbers. 6 divided by 2 is 3. 90 divided by 2 is 45. 45 is also divisible by 3. If I do, that's my division sign right now, 45 divided by 3, I get 15. So I have a 1 in 15 chance. These marbles are placed in the bag, randomly drawn. What's the probability of drawing 2 yellow marbles if the first is placed back in the bag? Okay, so we have a 2 in 10 chance of drawing a yellow marble on our first draw, and that marble gets placed back in the bag, so I get another 2 in 10 chance to get a yellow marble. That's a 10. Use your imagination. 2 times 2 is 4. 10 times 10 is 100. They're even, so you can divide by 2, or you can know that 100 is divisible by 4. 4 is obviously divisible by 4. 4 divided by 4 is 1. 100 divided by 4 is 25. So I have a 1 in 25 chance of getting B, yellow marble. When you roll a die, what kind of probability are you using? Well, rolling that die is not dependent on anything else. We're not waiting for a second roll. We're not doing a whole bunch of different die. We're just rolling one single die. So it's independent. All right. That is independent and dependent probability.